Hello dear students, welcome to the next lecture on Arduino programming. In previous lecture we had discussed about the Arduino hardware, wherein we have seen which microcontroller is used in Arduino and how it functions, different pins available in Arduino, the power requirement, the future enhancement of Arduino, and many more things. Now in today's session we are going to talk about the Arduino programming. Here we are going to discuss about the software part. Hardware already we had covered in previous session. Now in today's session, we are going to cover about the software part. The first thing, how to download and install the Arduino. And to do this, we need to follow some steps. And these steps are, we can download the Arduino compiler and the development environment, the Arduino IDE, from the link given here, that is arduino.cc/en/main/software. Or simply you can visit Google and type Arduino IDE, and there the first link will appear, which will be of arduino.cc. The current version available on the Arduino website is 2.2.1, and the Arduino is available for Windows, Mac OS, and Linux. Before running Arduino, you can plug the Arduino hardware using the USB cable through your laptop or desktop. The external power supply is not required. When you plug in directly through your computer, the Arduino hardware will get the power from your computer. When USB device is not recognized, navigate to and select the appropriate driver from the installation directly, and then you can run the Arduino. This is the way how you can connect your Arduino board with your laptop or desktop. There is a Arduino USB cable given along with the hardware. That cable you can connect to your Type-C or USB port of the laptop or the desktop, and the second port is connected through the Arduino hardware. Once you do that, then you need to open the Arduino IDE. When you install, after downloading the Arduino, when you install the Arduino IDE, then you can open the Arduino IDE, and that IDE will look like this screen. Here I'm using the old version of Arduino, which is 1.6.9, but right now in the market 2.2.1 is available. So this is the compiler screen, the compiler window, which will appear at the first. The first thing that we are going to learn is how to select the board. When we are connecting our Arduino Uno, then we need to tell this compiler that we are connecting with Arduino Uno. So to do that, under that Arduino compiler window, you can go to tools and then find boards. Under the boards, there will be n number of options available, the different type of Arduino boards available in the market. Out of all, you need to select the Arduino Uno, as we are using the Arduino Uno board. Select Arduino Uno, that's it. Now we'll learn how to select a serial port. When we are connecting our Arduino, our laptop or desktop will be connected through the Arduino through the serial port. So that we need to select, and to do that, again visit the tool menu and then go to serial port, and automatically the system is going to detect the COM port where the Arduino hardware is connected. This is the basic setting that we need to do, but it is not necessary that always we need to do this. Many of the times nowadays the Arduino is coming with some bootloader which automatically detects these settings. So we did not to do the same, but it may happen that in our computer it is not working or it is not detecting. Then we need to check these setup at the beginning. Now we are talking about the how to use the Arduino IDE, and before that we will see different parameters, or you can say the menus available on Arduino IDE. What are those menus and why those menus are, and how those menus can be used. So at the top you can see the first arrow. Here some content will be written, that is called as name of the sketch. The second, the right arrow, is the compile sketch. From here you can compile. The next, this particular area is the program area. This symbol is for new. This up arrow symbol is to open. Down arrow symbol is to save. This part is serial monitor, and at the bottom you have the message or the errors. We'll talk about all these in detail in coming slides. The first one, the write symbol, is actually a compiler and it verifies. It is also called as verify button. It compiles and approves your code and it catches all the errors which are there in your program. The next one, the write arrow, it is used to upload and it sends your code to the board. When you click it, you should see light on your board blink rapidly. That you need to take care. When the light rapidly blinks on your hardware, you can understand that the files, the codes, the compiled codes are being uploaded into your Arduino hardware. The next one is new. If you have already written program into your system, into your compiler IDE, and you want to open that particular file, then you can use this particular thing and it will open a new code window tab. The next one is up arrow, and which is used to open the existing sketch which is available on the Arduino board. Next, the down arrow, it is used to save the opened sketch. At the right hand side, you can see there is a search button type of symbol, which is actually used as serial monitor, and it opens a window that displays any serial info on the board that is transmitting. It is very useful when we are debugging something. At the top of void setup, you will find something written here. It is written as sketch underscore OCT07B. This is the sketch name. Sketch is your program, and whatever name to your program you are going to give, that will be written over there. The remaining white part that you can see here is your code area, wherein you need to write the instructions so that can be given to the Arduino, and Arduino can execute that after compiling it. It is basically used as a message area. When we compile or when we execute or when we upload whatever messages or whatever errors in your program you might be having, all those things are displayed at the bottom at this particular place. Now I will show you how to download and install the Arduino IDE in your computer. So simply visit Google and type Arduino. You will find the first link written as Arduino Home. The website is www.arduino.cc. Click simply on this particular link. You will be directed to the Arduino website. This is the official website. You can create your account in this website and you can be a part of the Arduino community also. Here, when you will reach at this particular page, you will find different tabs available. You can visit those tabs and you can know more about the Arduino. Like the first one is hardware. So here, when you will go, it will give you all the information about different Arduino boards, different family of Arduinos, different type of shields available, and many more things. Similarly, on the software, you will find different software versions available for different type of the operating systems. You can download it from here. So here, the currently available, the latest version is Arduino IDE 2.2.1. You can download this Arduino IDE 2.2.1 for Windows 10 and newer, for 64-bit, Windows MSI installer, Windows zip file, Linux zip file, Mac OS, etc. Or you can download the things from here. So first of all, I am using the Windows version of Windows 10. So I will click here. Now it will ask me to download Arduino IDE and to support for its progress. So if you want to contribute something, you can simply click on some amount and you can pay. Otherwise, it is for free. You can click simply on just download. Once you click simply on just download, it will ask you to enter your email ID, then click on these two terms and conditions, and then click on subscribe and download, or elsewhere you can simply click on just download. When you will click simply on just download, Arduino IDE will be stored somewhere on your hard disk. You can simply save it. It will take some time to be downloaded. Once it will be downloaded, then you can simply click on that file. Let me show you. The Arduino setup file is downloaded on my desktop. So simply you can click on this file, and then you need to click on terms and conditions. I agree. Next, and then the software will get installed into your system. It will take some time to install the software. I had installed Arduino earlier, so now when I am reinstalling, it has uninstalled the previous version, and now at this moment it is installing the Arduino 2.2.1. Once it will be installed, how to open it, how to use it. So the Arduino is installed completely on my computer. You can see here at the bottom, the shortcut to open the Arduino has come. I can directly click here and I can run the Arduino IDE, but as of now, I'll show you how to open it. So finish. Now, once the Arduino software is installed onto your computer, you will find one shortcut on your desktop. Simply double click on that icon. The Arduino will open for the first time on your computer. Because it is for the first time, it is taking some time. Otherwise, it will not take this much time. This is the Arduino compiler. And now you can see it is different than what we had seen previously. But things will remain the same. One by one, we can see this is the open folder. This is to save. Some other things are available over here. This is verify. This is upload. This is to debug. Now here under the file menu, we have new sketch, new cloud sketch, open, sketchbook, examples. One more thing about the example. When you open this example, you will find different programs readily available to use. You can use any of the program. The programs are written like blinking LED program here that we are going to practice for the first time is already readily available. Similarly, different programs are available. These are the built-in examples given by Arduino to understand how the Arduino functions. Then close, save, save as, preferences, advanced, etc., etc. Similarly, under the edit menu, different options are available. You can use this option as and when required. This is the verify or compile. This is to upload. This is to upload using programmer, export, compile binary, and many more options are available like this. So here you can go simply to Arduino boards and then Arduino AVR boards. We can select Arduino Uno so that the program will be written for Arduino Uno. Similarly, if I would have connected my hardware, then in serial monitor, it could have shown you the thing, but because I have not connected, so that's why I am not getting anything here. Okay, so different options are available. You can explore these options. And this is the program body. We are going to talk about this program body, the program structure, how this program works, and how to write the first program. So here you can see it is starting by default. It is here you can see by default it is written as void setup, opening bracket, and then after closing bracket. And here it is written as put your setup code here to run once. And then after the second part of the program is void loop, opening bracket. And here it is written as put your main code here to run repeatedly, and then closing bracket. So if we will talk about this Arduino coding, It is basically combination of two different functions. First one is called as the setup function, and second one is called as the loop function. The setup function is basically used to put all the requirements or all the setups, and the loop function is used to perform the task which we want to execute using the Arduino. Dear students, now we'll see how to do the experiments using the Arduino. The Arduino IDE that we have studied previously is not a good platform, or you can consider is not a platform wherein without having physical device you can perform the experiment. So you need to have the physical device which will be connected through your computer, and then only you can do the experiments. If you don't have hardware, then what to do? And for that you can use this simulation tool. This is online simulation tool named as tinkercad.com. Simply type tinkercad.com on the address bar of your browser. You will be directed to a website that is called as tinkercad.com. Here you can see many things available. First of all, you need to do the sign up, and you can, as a student, you can sign up, or elsewhere you can create your personal account. So use any of the feature and then sign in with Google. You can simply sign in into your account by using your Google IDs. I have already created my ID into this particular. After the sign up, you will be directed to the page where you are getting different options. I had my account as a teacher, so I'm getting different options. As a student, you will get different options. Here in this particular account, you can see different options will be available. This Tinkercad, whenever you will click here, you will be directed to the home page. This is the home page. Now under this Tinker, you will find multiple options like 3D designs, circuits, code blocks, SimLab, iPad app, Autodesk Fusion 360-degree. Now this is the place from where we can and perform the experiment. Next is the gallery, then project. This is interesting. When you will click on the project, there might be different projects developed by different community people. Those projects are available here. Under the project, you can go and find different things. Like if you want to go into the circuits, then people might have created different projects based on the Arduino. You can see here tic-tac-toe game on Arduino for beginners someone had created. So these type of the projects are available, and these projects you can learn from here, and you can do the experiment, or you can make your own project. This community is also very big community, wherein people are coming and giving their projects, uploading their projects into the system. You also can do the same. Then the classroom option is available. If your teacher has created the classroom, then there you can join, and whatever assignments or whatever questions, queries will be given by your teacher, that will come here at this particular place. And then the last one is resources, wherein you can get into the Tinkercad block, the learning center, the lesson plan, and other features are available. Here my concern is to talk about the circuit. So simply click on the circuit, and then once you will click on the circuit, you will be directed to the Tinkercad circuit page. And then here you need to click on start tinkering or join class. If your teacher might have given you the class code, then you can simply click on the join class. It will ask you the class code, enter the class code. You will be admitted into that particular class by the approval of your teacher. Otherwise, start tinkering, you can click, and this is going to provide you one platform wherein you can do different projects. This is basically a desktop for the circuit creation. Here go to the designs, and then the option will come create. It will ask you your designs, create circuits, etc. Already I have account into this particular website, so that's why it is showing different circuits to me. And you can simply click on create. When you click on create, it will ask you want to create a 3D design or circuit or the code blocks. We want to create a circuit, so click on the circuit. Then a new window will appear on your screen, and that window is going to give you some details. Now I will explain you few parts of this particular. Uh, Again, here when you will click, it will take you to Tinkercad dashboard. This is the name of the particular project. If you want, you can click here and simply change my first project. Then this is the workspace wherein you have to do all your experiments. You have to create your circuit. This is the place. This is the code in which you will get. As of now, nothing, because I have not created any particular circuit. Then this is start simulation, and this is send to. If you want to share with the people and apps, then you can simply send it to people or the apps. This is the component section wherein multiple options will come when you click on drop down, and that includes basics, all, Arduino, micro, circuit assemblies, etc. etc. You can keep it on basic or you can keep it on all. This is the component directory from where you will get different type of the components. You can see here resistor, LEDs, push button, and many components are there. The components which are not visible here, if you want to find all the components, sensor, actuators, etc. are available here. If you want to find some components, simply you can type, like I am typing Arduino. So Arduino Uno R3 will come. When I'm clicking here, the component is given, that is Arduino Uno R3, or elsewhere the circuits which are available into this platform, already built circuits are available into this platform, are also appearing. And if you click on some of them, it will simply take you to that particular. Along with the program, you will get the entire code, or elsewhere you can simply click here, and then when you click and drop at your workspace, you can get this. Now if you want to rotate this, click here, you can rotate. If you want to place somewhere else, click, put your mouse over that component and then rotate it. If you want to undo, you can click here and undo. If you want to delete, from here you can delete. If you want to create a copy of the component, you can simply create a copy of the component. And this is the for wire color. If you want, whatever wiring you are using, if you want to change the wire color, from here you can change the wire color. The wire type you can change from here. These are the things available at this particular part. At the next section, you will get code. The code, now it will appear. It is providing you the facility of doing the coding using three different mechanisms. The first one is called as the block coding. The second one is called as the block plus text coding. And the third one is called as the text coding. The block coding is the easiest method of learning the Arduino codes. And at the same time, block plus text, when you put the block on your workplace, then automatically the text for that particular block will appear. Or the third one is only the text. If you know how to do the Arduino programming, then you can simply type your code at the third option. Under this, you may find output, control, input, math, notation, and variables. When you click on each icon, you will get different options. We'll talk about these options later on when we'll do the experiment. And this is the workspace for the coding. So let me delete all these things and let me show you. Suppose you want to write a code for blinking an LED. That will be our first program soon that we are going to do. So simply you can put this, you can select forever. You want to blink it forever, so select that forever, keep it here, drag it here on the program workspace, and then whatever output you want, select something, keep it there like this. In this way, you can write the program using the blocks. The logic you need to understand, and then accordingly, if I'll click on block plus text, then the text for this, whatever I have written, I have blocks I have included over here. For all those things, the code will come over here. Once your program is ready, then you need to click on start simulation. When you click on start simulation, the circuit will get enabled and your Arduino will start working as per the code. So now at this moment, we have not created any particular circuit. That's why the Arduino is not going to give you the output. This is all about the look and feel of this particular platform. Now we'll go and we'll do the first experiment, and that experiment is blinking LED program. So let's get ready to start with the blinking LED program. Dear students, till now we have seen how to use the Tinkercad application. Now I will give you the demonstration of the first program that we are going to execute using the Tinkercad application, the Tinkercad simulation. And this will be the blinking LED program. Just like in any of the programming language, you use Hello World program at the beginning. Here in embedded systems, we normally execute the first program as blinking LED program. So the same program we are going to execute today. I will show you how to use this Tinkercad application and how to write the code using this Tinkercad application. To begin with, I am not going to talk much about the programming using the Arduino because you all might not be having Arduino at your home. I am going to explain you the concept using the block coding. As I told you earlier that the block coding is an easiest method of coding for any compiler. So here, when you will open the Tinkercad, you will find this window. In this particular window, you will find the components written under is basic. You can click here and you will get multiple options. Let me to go with the basic. Now here you are having the search for components. Type here Arduino. You will get multiple options like Arduino Uno R3. Click there. You will find n number of Arduino boards. As I told you earlier that don't go and don't use any pre-ready material or the program. Simply we will learn how to create a circuit. So simply click on Arduino and then drag at the other part. Let me minimize the screen so that I can show you. So here I am putting my Arduino board. When you will click the left hand side, you will find Arduino Uno R3 and name. If you want, you can give the name to this Arduino as ARD1 or whatever name you want to give to this particular Arduino. So we have kept one Arduino. Now we have to create a circuit. And we know that when we need to create a circuit, we can create a circuit like this is my device. And here, if I'll connect one LED will blink. But we know that we cannot connect directly any component to the device. So what we are going to do is we are going to select some resistor and LED. So next component that I am going to search here is the resistor. When I will type resistor, here I'll get some options. First option here, it is coming as resistor. Click this simply and drop it somewhere on your screen. So I'm keeping the LED, let us consider I'm keeping the LED over here. Okay. If you want to give the name, you can give the name to this LED as R1 and it is in kilo ohms. If you want, you can change the value of the resistance. Let it be in kilo ohm only. It is having a capacity of 1 kilo ohm. Now the next is we need LED. We want to blink the LED, so we need to use the LED. Again, go to the component section and type LED. When you will type LED, multiple options will come. Click on the LED. You will see multiple LEDs. Now we are talking about the red, green or blue LED. So it is 2 legs LED. Simply click here and put it somewhere here like this. Now the LED name and color you can change. So here when I will click on this LED, like let me click somewhere else and then I will show you. When I am clicking here, this message box will appear and it is going to show you the name and the property of the LED. So I'll put the name as LED1 and color. There are multiple options available here. You can select any one option out of all. So here, green, yellow, orange, blue, red, white. I want to use green light. So now the green LED, you can see here, click somewhere outside. Now we need to create the circuit. The LED has the anode and the cathode button. Simply I will go to the end terminal of this resistance. Then it will, when I'm clicking the mouse at the end of the resistance, it is showing me terminal 1. Now click there and then drag at the top. You can see here the circuit is being created. The wire is connected. Simply drop there. So this LED is connected. Now the second terminal here, suppose I am using pin number 8. So I'll drag and drop once you click, and then after drop at pin number 8. So it is connected through pin number 8. Now the next pin I need to connect to the ground. So I'll simply click there and I'll put it here on the ground. So my circuit is created. Now I need to write the code for this particular. So simply click on the code. And as I told you earlier, that it is going to give me the options of block coding as well as block plus text coding. Because it is the first program, I am simply selecting the block coding, and then later on I will show you the same program using block and text coding also. So I am simply clicking on block coding. So I am going to get the blocks here. It is giving me different options already at the right hand side. You can see. Now I don't want to use this. So if I want, I can simply click, right click and delete block, right click, delete 5 blocks. So my workspace is now empty. I will select as per my circuit. I can now create the program using the block coding. The block coding is quite simple. And here it is giving you 6 different options. The first option is output. When this concept of output and input, you need to remember. If you want to give some input to external device from the Arduino, it means your Arduino is going to give some content to the outside circuit or to outside component, then we are selecting the output. And when, if some sensors or some external circuit is giving some value and that I need to accept in Arduino, then I will select that as input. Okay, so you may understand what exactly is the output and what is input. Output is what? When the Arduino is giving something as input to some other component outside the Arduino board, then we are selecting the output. And if some outside component is giving some value and that we need to take as input inside the Arduino for the purpose of processing, then we are considering that as input. Now notation, simply if you want to write some comment, then the notation part can be used. I will simply use this notation or the comment, but right now I don't require in my circuit. The next is the control, and the control says that whenever you are writing any particular program, what you want to do on start, or if you want to run that particular program for forever, then you can use this particular block, forever block. If you want to run your program by putting some wait condition, it means if you want to give delay on your program, then you can use this wait. You can change the value here in seconds or in minutes. If you want to repeat something continuously, then we can use this repeat and we can put some values inside this block. Like here it is written as 10. We can change it, and that number of times the circuit is going to execute. Then if you want to repeat by putting some condition. You can use repeat while condition, and similarly, let me go down. If you want, if you have some condition like if then else, then you can use this one. If you want to count and other things, then other options are available. As and when we will grow, we will understand how to use this Arduino block codes. We will use other options available under the control. If you have some mathematical operation and you need to perform some mathematical operation, then we are going to use these things. If you need to declare some variable in your program, like we know in programming, variable declaration is very much important. So if you need to declare some variable wherein you will assign some data types and you want to store some data into that, then the variable part can be used here. You need to create the variable by your own. Simulation tool is not going to give you any variable as per their choice, but you can create the variables by your own. So simply in this particular example, I don't need to do anything. I need to repeat some tasks. So first of all, I will go to the control part, and then I will use the forever because I want to blink my LED forever. So I'll put forever. I'll drag the forever from there to my workspace like this. Now the forever button has come over here. Now what I want to do is I want to give input to my LED, and I want to send 1 or 0. As we have studied earlier, when we studied about the signal, that we are going to transmit the digital signals, and pin number 8 is the digital signal where I want to give some value. So here what I'm going to do is I will use either this set built-in LED, but this built-in LED is something which is available over here, the built-in LED that I cannot use. So the next one is set pin. Now I have connected my LED with pin number 8. So this is suitable for me, and I can use this or set pin to 0. So either in terms of high or low I can give input, or in terms of 0 and 1 I can give input. So let me select this set pin 0 to high. Now I have selected set pin 0 to high. So it is going to give the input to pin number 0, but here I have connected my LED to pin number 8. So let me change this. I will go click on the drop down. It will show me the pin number. So there are 13 pins, those are digital, and then A0 to A5, 6 analog pins. My LED is connected to pin number 8, so I will select that, and that I'm keeping as high. Now the LED will glow. Okay, let me see once how it works. So I exit from the code section, and now I'm clicking on start simulation. So when I'm doing the simulation, you can see here the LED is glowing and one eye symbol is coming at the top. When I'm keeping my mouse over that eye, it is showing current through the LED is 53.5 milliampere, while recommended maximum is 20 milliampere. The usable lifetime of the LED may be reduced. So this Tinkercad simulation, circuit simulation tool is nowadays based on AI, and it is going to give you the hint that the current which you are sending to the LED, that amount of the current is pretty much higher than the required current. So you need to reduce the current. And we have already studied previously that if you will apply more amount of the resistance in the circuit, then this current will get reduced. So we need to increase the value of the resistance so that we can reduce it by half, because 53.5 milliampere is currently transmitted, but I need 20 milliampere of the current only. So I need to double the value of resistance or more than double so that I'll get less amount of the current. So let me do that. Again, you can click somewhere and then go to first stop simulation. I cannot simply do anything as of now here. I need to stop the simulation. Click on stop simulation. Again, click on LED. This LED option will come, and then you need to change the, if you want to change the color, you can change. I need to, sorry, I need to change the value of the resistance. So I will click on the resistance and name is something, and that resistance value is not given. So I will keep suppose 2 kilo ohm. Okay, I'll keep the value 2 kilo ohm. Now kilo ohm. Now let me again start. So here now you're not getting any error. Okay, so 2 kilo ohm resistance is sufficient enough so that your LED will get 20 milliampere of the current or less than that amount of the current. Okay, so you can see this. Now if suppose I will change again, stop simulation, click on resistance. Suppose in place of 2 kilo ohm I am keeping 220. In place of kilo ohm I am putting it as ohm. Okay, now let me see how it goes. Start simulation. It is glowing and it is not giving you the error. Okay, now let me change again to 1 ohm. Let me see. Now the error is coming here again. So in this way I can change the value of the resistance to suppose 100 ohms. That will be sufficient, I believe. And here I am not getting the error. Now you will say, sir, why you have changed from 2 kilo ohm to 100 ohms? The reason behind this is, if I'll keep more and more amount of the resistance, then the current which will flow through the LED will be lesser and lesser if you are keeping more and more amount of resistance. In that situation, the intensity of the light that you will be getting from the LED will be less. So if you want a perfectly bright light from that LED, then you need to take the value of the resistance somewhere so that it will give you the current, it will give you the required brightness. Okay, so this is how we can do it. But here it is not blinking. My problem is to write a program to blink the LED, and here this particular is not blinking at all. So I need to somewhere do something so that it can blink. And to blink the LED, what we can do is, we need to understand the concept. Blinking means getting on and off. So I need to write a program in such a way that the LED will first be in on condition, and then soon the LED will become in off condition. So I need to repeatedly do the same procedure on and off so that the LED will start blinking. So for that, again, I need to go on the code. We have written the program where the LED is glowing forever. Pin number 8, we are giving high, and forever we are giving high to this pin number 8. Now what changes we need to do is, again, I'll go to the output, and then I need to set my pin to 0. So let me do it incorrectly first, then I will correct so that I can explain you something. So I will again set pin this over here, and I'll put this like this, and then pin number, my pin is 8, and earlier it was high, now I will change it to low. Okay, so what I'm doing is, pin number 8 putting at the beginning high, and then pin number 8 putting as low. Now let me run this program, and you need to see the LED very carefully. Okay, so see this LED. For fraction of time it glows, and then the LED is in off condition. Why it is happening? The reason is when I'm writing the code, first I'm saying on, and then after I'm saying off. So in the fraction of the second, when the first code, when I'm putting my LED in on condition, at the same time after execution of that particular code in microseconds, I am saying that now you should go to off condition. So my eyes are not capable enough to see that value when the LED is going into on and off. So what I need to do is I need some delay in between, so that I can see the LED to be in on and then in off condition. And for that we can go into controls, and then we will use some wait condition, the delay, and I'll select wait for 1 second, and I'll put it in between this. Okay, now we will see how it works. Okay, now let me start. Before starting this, I must tell you it may not give you the correct output as required, but let's see. Still it is not blinking. Why? It is always in on condition, that we can see. The reason behind this is, when I'm keeping something in on condition and then telling to wait for 1 second, that LED will remain for on in for 1 second, and then after I'm saying it to be in off condition. Okay, so at the beginning here, your LED, let me annotate. Yeah, so here in this particular program, I'm first saying that keep the LED in on condition. So your LED from the pin number 8, it is now in on condition, and then I'm waiting for one particular second. So I'm waiting for 1 second, so it is in on condition for the next 1 second, and then I'm giving the instruction as set the LED to low. It means now the LED should be in off condition, and now the LED will remain in off condition for how much time we have not defined. So fraction of the second, the LED will go into off condition, and then because we are into the forever loop, so from after this the LED will again go to on condition. Now when we see this, we need to understand, if we write a single line, if we make a mistake on a single line of the code, then the output will differ. So the problem is I need to put some wait condition after the low condition. Okay, so let me do that. And to do that, what we'll do is we will simply go on control, and then again wait, drag it and drop just below the low condition. So wait for 1 second. Now your blinking LED program is complete. I will explain the code again soon, but let's see first how it works. So go on to start simulation, click there. It is initializing. Now you can see your LED is getting into on and off, again on and off. So this is the way how we can write the first experiment. This is based on simulation. I will show you practically using the Arduino board. For that, I'll create another video and will show it to you how physically we use our Arduino board and we do the experiment. So you can see how the LED can go into on condition and off condition. To explain you the first experiment, blinking LED program, I have directly connected the component through the pins of Arduino. That is not a good practice. Actually, whenever we want to create any particular circuit, then we need to use the breadboard. Earlier, during first lecture, I had explained you how to use the breadboard. Recall that, or you can watch my first lecture video wherein I explained everything about the breadboard. You can use the breadboard to create the circuit. Okay, I will show you in the same experiment. I will now show you how to use the breadboard, and even we'll talk about the code. So let me explain the code first, and later we will use breadboard. So here we want our LED to blink forever. So as we will switch on the Arduino, the LED should blink forever. And for that, I'm using a control that is of forever. So when I'm using this forever block, the forever block will, without any particular, without keeping anything in mind, forever, whatever instructions will put inside that code here, that will be executed. Now, to blink the LED, we need to understand the concept of blinking. The concept of blinking says that keep something in on state and then after in off state, repeat the same thing forever. So what I'm doing is I have connected my LED to pin number 8. So I will give the input to pin number 8, that will be considered as output for my Arduino. So I am selecting set pin from the output. I'm selecting set pin number whatever I want to high, and then after I'm keeping the pin number as 8 and to high, and then after I'm waiting for some time so that from my eyes I can see those changes. So I'm waiting for 1 second, and then after I'm using the same thing, set pin number 8, and now this time I'm keeping it as low. A few of you might be having the question in mind, sir, why you used only set pin to high or set pin this to low option? Why not you have selected set pin to 0 or 1? So that also we can do. Let me make changes. Delete block and this delete block, delete block, delete block. Okay, right click and delete option will appear. So I'll use this 0 and 1. Set pin, my pin number is 8. Now here I am not getting the option of pins. I'm not getting the option of pins. Okay, so let me change my circuit. Why I want to use 3, 5, 6, 9, 10 and 11. So let me change 3, 5, 5. I will change this to, I will delete this part and I'll connect this to pin number 5. No problem. I want to use that only. So I'll do in this way. So code set pin number 5 to 1. Then wait for 1 second. Again output set pin number 5 to 0, and then after wait for, into the output, wait for 1 second. Let's see what happened when we are writing the code in this way. I'm using, in place of 8, I'm using now pin number 5. So start simulation, initializing, and you can see here also the light is glowing. Okay, and my LED is blinking. If I want, I can change the value of the resistance to 10 ohm, and you can see the light is working. Okay, so in this way you can execute the program. Now what to do? First of all, you need to understand how to write a program, how to use this Tinkercad, and for that you need to log in, create your account, sign up into Tinkercad. Using your mobile phone, you can do all these experiment. You don't require any computer, any hardware, anything in Arduino and drone programming. We can do everything using simulation. Okay, so that's why today you need to create your account into Tinkercad website, and then after once you created your account into Tinkercad website, you need to simply go into the circuits, your designs, then into circuits, create your own LED program. And as I told you that this LED circuit that I have created for blinking LED program is not the correct way to do the operation. The better way or the suggested way is to use the breadboard. Now I am showing the same experiment using the same code into the breadboard. So let me stop the simulation. Let me delete the code also. I don't want to use this code. Let me delete. Okay. I will create a new circuit. Let me delete all the components, select and press delete button. It will be deleted. Okay. Now I need to use the breadboard, and for that I can minimize. And for that I can click on the control button of my computer and then drag it so that I can minimize. If you want to rotate, select your board, then you can rotate like this. So I want more space, so I will rotate like this. If you want to delete, select the component, click here and you can delete. If you want to undo, you can click here and go and undo. If you want to redo something, you can click here and redo. If you want to copy, you can select the component and copy the component also. This is the wire color, what wire color you want. Normally it is suggested that for positive you go for green, sorry, zero you go ground, you can go for green, and for positive you can go for the red one. Similarly, the wire type you can change, normal wire, hookup wire, or alligator wire, or anything like that. So multiple options you will get. As and when we will explore this platform, we will come to know more about this platform. So as of now, I want to use the breadboard and I want to blink the LED. So simply type here sorry, delete, and then BREAD, breadboard. I want a small breadboard because my operation is not, my circuit is not a big circuit. So breadboard small, you will get the option breadboard small. Drag it and keep it somewhere near this. Okay, so I am keeping here so that I can show you it, show everything to you properly. Now what I need is I need LED and resistor. So I'll search for LED. Already it will come here now. So LED, I will drag my LED and I will keep my LED somewhere between these two. So my LED I'm putting here like this. Okay, I'm keeping my LED over here. Okay, now when I'm going, it is cathode and this is anode. Okay, now I need to create the circuit, and for that I need to use the resistor. So I cannot directly connect it, so resistor I need to use. So I'll put the resistor between this. Now when I'm using this way, when I'm using in this way, then we know that this is not connected, so the resistance will be offer, and the vertical part you can see green symbol at the bottom. So vertically it is same power is supplied, same current is supplied, and at the bottom side horizontally the same amount of voltage or current is applied. So I will connect like this. and this one I need to connect with the ground. So from here, the second terminal, I will move one wire to the ground. Let me check, it is ground. Okay. Okay, so this I have connected to ground, and this one from anywhere I can connect. So I will use this one and I will connect it to pin number 8 I had used earlier. So I will use the pin number 8 only. Okay, so now my circuit is created. You can see, let me increase the size so that I can show you. Okay, so this is the circuit that I have created. Now I'll go to the code again, block forever, then output, set pin number 8. I have selected 8 to either high or low. Let me do it now low. Then go to control, wait for 1 second. Again go to output, set pin number 8 to, earlier it was low, so now it will be high, pin number 8, and then again go to control and wait for 1 second. My code is ready. Now we'll see how it works. So you can see the LED is now blinking. The value of the resistance I have not defined, it is 1 kilo ohm. So let me put it in ohm. देखो 100 or 10. Let me keep it 100 so that I will not get any error. Yeah, so your LED is blinking in this way. Okay, this is the correct way of creating the power, or elsewhere I will show you one more thing here in this circuit only. Let me show you that also, to use these horizontal pins. Okay, let me stop my simulation, remove the circuits, the wires I'm removing first. Let the components be like that only, and I know that I need to apply the power, so I'm doing like this, and then I'm giving the input to this. Okay, what I'm doing is, pin number 8 is my input terminal, which I'm going to connect from this. So I will connect like this. So here in all the pins, 8 number input will be given. So I will connect this resistor somewhere, this to this. Okay, I have connected this, and then ground I need to connect. So ground, and that ground I will keep at the top, or let us consider at this point. Okay, ground here. So now this one is ground, so this I need to connect at the top. Okay, so this is also the way of creation of the circuit, a perfect way. Okay, so here in all last row, everywhere the input from pin number 8 will go, and at the top everywhere the ground will go. Okay, now let me start the simulation. So similarly your device is working. If you want to add using the same pin, you want red, green, yellow, like that type of component, you can do it like I'm doing right now. Okay, one resistor, and this will be connected to the bottom one, and this will be connected to, okay, now one more resistor I want to connect, sorry, LED I want to connect, and the resistor, again I have not changed the value of the resistances, that I'll do soon, and this will be connected at the bottom. Now this point will be connected to the ground. Then I want one more here. So let me put the resistor.
and it will be at the bottom, and this will be at here. Okay, so this is red. Let me keep this as green, green, again red, again this will I'll put as green. Okay, now let's check. Okay, so you can see here that the four LEDs using the same pin, pin number 8 is my input, and the same input is given to all the pins, and at the same time the pins are working, getting on and off, getting on and off. You can change the color of the LED like red, then yellow, then this one orange, then this one green, etc, etc. Okay, so this is the way how we can use the Arduino, we can create our circuit, and I hope you all might have enjoyed this lecture. Now I'm stopping at this moment, and we'll talk about some more programs, some different type of the experiments we'll do in the next lecture. Thank you all. If you enjoyed this lecture, give thumbs up, and don't forget to subscribe my channel, the bell notification, click there so that you will get the information about all my upcoming lectures. Thank you.